Have you ever actually grabbed a piece of raw, unprocessed bamboo? If you have, you'll know exactly what it feels like. It is incredibly hard, impossibly rigid, and notorious for giving some of the sharpest, most painful splinters imaginable. In the wild, it is tough enough to be used as scaffolding for skyscrapers, strong enough to build bridges, and durable enough to withstand hurricane-force winds. Now, picture a high-end luxury t-shirt, the kind that feels cool to the touch, drapes perfectly, and is so incredibly soft it practically melts in your hands. It feels softer than premium Egyptian cotton. It feels softer than silk. Would you believe me if I told you that these two totally opposite things are the exact same material? How do we take one of the most stubborn woody plants on planet Earth and transform it into a fabric so delicate that luxury brands charge hundreds of dollars for a single shirt? It doesn't make any logical sense. You can't just spin wood into yarn. The journey from a towering green stalk in a dense forest to the ultra-soft shirt on your back involves a mind-bending factory process, heavy industrial engineering, and a chemical magic trick that fundamentally alters the molecular structure of the plant itself. And somewhere along the way, we have to ask a massive question that the fashion industry doesn't always want to answer. Is this supposedly miracle, eco-friendly fabric actually as natural as they claim? Welcome to Huzaif Beyond. Today, we are stepping inside the hidden, highly secretive factory process to uncover the fascinating, brutal, and brilliantly engineered life cycle of bamboo clothing. To understand the transformation, we have to start at the source. And the very first thing you need to understand about bamboo is that it is a biological anomaly. It looks like a tree, it acts like a tree, but it is actually a species of grass. And it is the fastest growing plant on the entire planet. While a cotton field requires massive amounts of water, careful tending, and months of waiting, certain species of bamboo can grow up to 35 inches in a single day. You can literally sit in a silent bamboo forest and hear the plants growing. They don't require replanting after harvest. They don't need pesticides, and they survive on rainwater alone. This hyper-efficiency is exactly why manufacturers became obsessed with it. It is an infinite, rapidly renewing resource. But having a lot of bamboo doesn't solve the main problem. It is still hard wood. The transformation begins with the harvest. Workers navigate dense, towering groves, cutting mature stalks that are usually 3 to 4 years old. This is the sweet spot where the bamboo has hardened enough to yield a maximum cellulose, but isn't so old that it becomes brittle. The massive, heavy stalks are bundled, loaded onto trucks, and transported to the processing facility. When you stand on the floor of a bamboo processing plant, the sheer scale is deafening. Mountains of green and brown stalks are fed into massive, terrifying industrial chippers. The machines roar as steel blades spinning at thousands of rotations per minute violently chew through the rock-hard bamboo. In seconds, what was once a 40-foot stalk is reduced to millions of rough, jagged little wood chips. But a wood chip is still wood. You can't weave a wood chip. To make fabric, we have to completely destroy the physical form of the bamboo and extract its secret weapon: cellulose. Cellulose is the structural component of the primary cell wall of green plants. It is the natural polymer that makes wood strong. But if you can isolate it, if you can strip away all the other plant matter, cellulose can be reshaped. This is where the brutal breakdown phase begins. The millions of bamboo chips are loaded into giant pressurized digester vats. Imagine a pressure cooker, but the size of a 3-story building. Inside these vats, the chips are submerged in a chemical bath. usually a strong solution of sodium hydroxide, which is more commonly known as lye. The heat is cranked up, the pressure builds, and the vat effectively boils the bamboo. This isn't a gentle wash. This is a violent chemical dismantling. The lye breaks down the lignin, the natural glue that holds the plant cells together. As the hours pass, the hard, jagged chips begin to dissolve. The rigid structure collapses. What started as wood is broken down into a thick, murky, soupy pulp. This pulp is then washed, bleached to remove the natural brown and green colors, and dried into massive, thick sheets. If you look at these sheets, they resemble thick, heavy watercolor paper or crude cardboard. We have successfully stripped the bamboo down to pure cellulose, but we still have a massive problem. We just have sheets of hard paper. How do you turn a sheet of stiff paper into a thread that you can actually sew? This is the exact moment where the factory process shifts from brute force engineering to a delicate, microscopic chemical magic trick. This process is the heart of the entire operation, and it is the secret to why bamboo clothing feels the way it does. The thick sheets of dried bamboo cellulose are taken to the spinning facility. But we aren't spinning cotton or wool here. We have to melt the cellulose down and rebuild it from scratch. The sheets are shredded into a fluffy white crumb. This crumb is aged under strictly controlled temperature and humidity conditions, allowing the molecules to naturally begin breaking apart. Then comes the most critical chemical reaction in the entire factory. The aged crumb is mixed with a chemical solvent called carbon disulfide. When the carbon disulfide hits the cellulose, an incredible transformation takes place. The white, fluffy crumbs turn a deep, vibrant, glowing orange. The chemical structure of the cellulose has been fundamentally altered, creating a new substance called cellulose xanthate. This bright orange substance is then dissolved one final time into a dilute solution of sodium hydroxide. The result is a thick, sticky, highly viscous liquid that looks and pours a lot like golden honey. This liquid is called viscose. This is a profound moment in the manufacturing process. The plant is completely gone. The wood is gone. The paper is gone. All that remains is a thick golden syrup. The bamboo has been liquefied. But a liquid isn't a fabric. We need thread. And to get thread, the factory relies on a piece of machinery that is an absolute marvel of modern engineering: the spinneret. Imagine the showerhead in your bathroom, but instead of a few dozen large holes, the spinneret is a tiny, precision-engineered metal plate containing hundreds, sometimes thousands, of microscopic holes. These holes are so small they are barely visible to the naked human eye. The golden, honey-like viscose liquid is pumped under immense pressure through the microscopic holes of the spinneret. But here is the genius part. The spinneret is fully submerged in a massive bath of sulfuric acid. The very microsecond the liquid viscose squeezes out of the tiny holes and touches the acid bath, a violent chemical reaction occurs. The acid instantly neutralizes the solvent, causing the liquid to coagulate and solidify on contact. It is mesmerizing to watch. A thick, golden liquid goes in, and thousands of perfectly solid, microscopic continuous filaments of pure cellulose emerge on the other side. Liquid becomes solid thread in the blink of an eye. These filaments are caught by high-speed mechanical rollers, pulled taut and drawn out of the acid bath. The pulling action aligns the molecules, giving the newly born fibers incredible tensile strength. They are washed repeatedly to strip away any remaining acid and chemicals, leaving behind pure, bright white threads. We have finally done it. We have turned a hard, splintery plant into a soft, flexible yarn. This specific process creates what the fashion industry calls regenerated cellulose. The fabric you buy might say bamboo on the tag, but from a purely scientific standpoint, it is bamboo viscose. But before we move on to how this yarn becomes a luxury shirt, we have to address the elephant in the room. The curiosity loop that surrounds the entire bamboo clothing industry. Is this process actually eco-friendly? Brands love to market bamboo as the ultimate green miracle. And on the farming side, it absolutely is. It saves water, stops soil erosion, and absorbs massive amounts of carbon dioxide. But as we just discovered, the factory process requires sodium hydroxide, carbon disulfide, and sulfuric acid. In traditional, older factories, these chemicals can be highly toxic to workers and devastating to the local environment if they aren't properly captured and disposed of. This reality forced the industry to evolve. Today, the most premium and truly eco-friendly bamboo clothing isn't made using the traditional viscose process at all. It uses a revolutionary modern method called the Lyocell process. In a Lyocell factory, instead of using toxic carbon disulfide, the bamboo pulp is dissolved using a non-toxic organic solvent. But the real genius of the Lyocell process is that it is a closed-loop system. That means 99% of the water and chemicals used to melt the bamboo are captured, recovered, and reused over and over again for the next batch. Nothing goes into the rivers. Nothing goes into the atmosphere. It is a masterpiece of sustainable chemical engineering, combining the incredible growth rate of raw bamboo with a zero-waste factory process. Whether it is traditional viscose or modern lyocell, the microscopic threads are now ready for the next phase. They are chopped into shorter lengths called staple fibers and baled up exactly like raw cotton. From here, the factory looks a lot more like a traditional textile mill. Massive automated spinning machines take the raw, fluffy bamboo fibers and twist them tightly together, drawing them out into thousands of miles of strong, continuous yarn. The yarn is wound onto giant industrial spools that weigh hundreds of pounds, ready for the weaving floor. When you walk onto the weaving and knitting floor of a modern textile facility, the vibration hits you in the chest. Hundreds of massive, computerized circular knitting machines are running at blinding speeds. Thousands of spools of bamboo yarn feed into the top of the machines, moving so fast they look like a blur. The needles click and clack, looping the yarn together with mathematical precision, producing an endless, seamless tube of bright white fabric that drops out of the bottom of the machine. Now we can finally answer the biggest question of all: the reason people buy this clothing in the first place. Why does it feel so incredibly soft? Why does this manufactured fabric feel better than high-grade natural cotton? The answer is invisible to the naked eye. If you take a strand of natural cotton and put it under an electron microscope, you will see that the fiber is naturally twisted, flat, and has a slightly rough, scaly surface. When millions of these rough fibers rub against your skin, it creates microfriction. But if you put a strand of bamboo viscose under that exact same microscope, it looks completely different. Because the bamboo fiber was extruded through the perfect microscopic holes of the spinneret, the fiber is perfectly smooth and perfectly round. There are no scales. There are no twists. It is a flawless cylinder. When millions of these perfectly smooth cylinders are woven together, they glide effortlessly across your skin. There is zero friction. That is the secret to the buttery, luxurious softness. It isn't just soft, it is geometrically perfect. Furthermore, those smooth, round fibers are highly porous. They naturally wick moisture away from the body and allow air to flow freely, which is why a bamboo shirt always feels distinctly cool to the touch, even on a blistering hot day. But the bright white fabric rolling off the knitting machines isn't finished yet. It has to go through the dyeing and finishing process. The massive rolls of fabric are loaded into high-pressure dyeing vats. Because regenerated cellulose is highly absorbent, it takes dye incredibly well. The colors penetrate deep into the core of the fiber, resulting in rich, vibrant hues that won't fade after just a few washes. Once dyed, the fabric is run through giant tensioning machines called stentors, which blast the fabric with steam and heat, locking the fibers in place so your shirt won't shrink the first time you put it in the dryer. Finally, the fabric is run through industrial softening rollers, enhancing that signature silky drape. We are in the final stretch. The fabric is rolled, inspected for any microscopic flaws, and shipped to the cutting and sewing facility. Here, automation and human skill work side by side. Massive, computerized cutting machines use vacuum tables to suck dozens of layers of bamboo fabric perfectly flat. A laser-guided blade slices through the fabric, cutting out the front, back, and sleeves of a t-shirt with millimeter precision in a matter of seconds. These precise fabric pieces are bundled and sent to the sewing lines. Highly skilled garment workers operating specialized industrial sergers and overlock sewing machines assemble the pieces at incredible speeds. They bind the seams, attach the collars, and fold the hems. Every stitch has to be perfect because this premium fabric demands premium construction. The finished shirts are meticulously inspected, steam-pressed to remove a single wrinkle, folded with robotic precision, tagged and boxed up for global shipping. The life cycle is complete. It is a journey of brutal extremes. It starts in the quiet, damp soil of a forest, where a stubborn grass grows at breakneck speed. It is violently chipped, boiled in chemicals, completely dissolved into a golden syrup, and reborn through a microscopic showerhead in a bath of acid. It is spun, knitted, dyed, and sewn. The next time you pull on a bamboo shirt and feel that incredible, heavy, silky softness against your skin, take a second to appreciate what you are actually wearing. You aren't just wearing a piece of clothing. You are wearing a triumph of human engineering. You are wearing a chemical masterpiece. You are wearing a piece of hard, splintery wood that science figured out how to melt into silk. Thank you for exploring with us, and we will see you in the next deep dive on Huzaif Beyond.